Chapter number 2, Polynomials. Now we have to learn about linear polynomial, quadratic polynomial and cubic polynomial. Also we have to learn zeros of a polynomial. In class 9, you have studied polynomials in one variable and their degrees. Now just we recall it. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. For example, 4x plus 2 is a polynomial in the variable x of degree 1. Now, a polynomial of degree 1 is called linear polynomial. A polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 3 is called cubic polynomial. How to find the degree? See, take this example. Here the polynomial is 4x plus 2. Here the highest power of the variable x is 1. So this is called linear polynomial. Take this example, 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. How this is possible? See the polynomial. The highest power of the polynomial is 2. So this is called quadratic polynomial. This is the example for cubic polynomial. See the polynomial 5x cube minus 4x square plus x minus root 2. This is the polynomial in the variable x. See the highest power. In this polynomial, 3 is the highest power of the polynomial. So this polynomial is the example for cubic polynomial. Take this polynomial 7u power 6 minus 3 by 2 into u power 4 plus 4u square plus u minus 8 is a polynomial in the variable u of degree 6, because here the highest power of the variable u is 6. So this is called degree. This is the variable u of degree 6. Expressions like 1 divided by x minus 1, root x plus 2, 1 divided by x square plus 2x plus 3 etc. are not polynomials. In generally, any linear polynomial in x is of the form ax plus b, where a and b are real numbers and a is not equal to 0. Here a is not equal to 0 because we put a equal to 0 in this term. What will happen? 0 into x, 0. The remaining term is only constant. So ax plus b, where a and b are real numbers and a is not equal to 0. Any quadratic polynomial in x is of the form ax square plus bx plus c, where a, b, c are real numbers and here also a is not equal to 0, because if we put 0 for A, what will happen? This first term is equal to 0. Then we will get bx plus c only. Bx plus c is the linear equation, not a quadratic equation. So this condition is very important. Any cubic polynomial in X is of the form ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers. And here also a is not equal to 0. Then we apply that same condition here also. For example, take any one of the polynomial. Now consider the polynomial p of x equal to x square minus 3x minus 4. Then putting x equal to 2 in the polynomial, we get p of 2 is equal to minus 6. Next, what is the value of p of x? What is the value of p of x? Equal to x square minus 3x minus 4 at x equal to 4. The polynomial is x square minus 3x minus 4. We putting 4 in this polynomial. The answer is 0. Here p of 4 is equal to 0. Also note that in the same polynomial, we put minus 1 for this polynomial. P of minus 1 also 0. Here 4 and minus 1 are called the zeros of the quadratic polynomial. X square minus 3x minus 4. That is, in generally, a real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. Again, in generally, a real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. This is the example for this. In general, if k is a 0 of p of x equal to x plus b, then p of k is equal to ak plus b, that is equal to 0. Then k is equal to minus b by a. That is, the 0 of the linear polynomial ax plus b is minus b divided by a. Here b is the constant term and a is the coefficient of x. Next, we have to learn geometrical meaning of the zeros of a polynomial. See the graph. Already you learned about graphs. See the graph. This is x-axis. This is y-axis. See children. See the graph. This is x-axis. This is y-axis. Before seeing this, we recall the quadrants. See, here x values as well as y values both are positive in first quadrant. This is second quadrant. Here x axis negative, y axis positive. So negative x coordinates negative, y coordinates positive. This is second quadrant. See the third quadrant. Both x-axis values and y-axis values both are negative only. So x value, y value, both values negative in third quadrant. See the fourth quadrant. Here x values positive, y values negative. Positive, negative. This is fourth quadrant. First, consider a linear polynomial ax plus b. A is not equal to 0. The graph y equal to ax plus b. That is, for example, the graph of y equal to 2x plus 3. X, y equal to 2x plus 3. Take the values for x minus 2 and 2. Apply these two values in this. We get minus 1, 7. So the points are minus 2, minus 1, 2, 7. Plot these points in this graph. Minus 2, minus 1. Where is minus 2, minus 1? See, first number minus 2 here in x-axis minus 2. Second one minus 1 is in y. This is minus 1. So minus 2, minus 1. This point is minus 2, minus 1. Like that, 2, 7. 2, 7. This point is 2, 7. Plot the points. Join the line. Y equal to 2x plus 3 is a straight line. This straight line intersect the x-axis at only one point. See, that point is in between minus 2 and minus 1. That is minus 3 by 2. So the intersecting point is minus 3 by 2 comma 0. So the graph y equal to 2x plus 3 intersect the x-axis at only one point. So here the number of zeros is 1 and the 0 of the polynomial is minus 3 by 2. In general, for a linear polynomial ax plus b, a is not equal to 0. The graph of y equal to ax plus b is a straight line which intersects the x-axis at exactly one point, namely minus b by a, comma 0. Take one more example for quadratic polynomial. Take the values for x minus 2 to 5. Y is equal to x square minus 3x minus 4. Apply each value in this y. We get the y values. See the graph. It is clear, very clear. Mark all the points. Join the points by a smooth curve. See this? This curve is called parabola. This is parabola. This is called open upward parabola. This curve intersects x-axis at 2 points. See, here one point, here also one point. This is minus 1. This point is 4. So here the number of polynomials are 2 because the curve intersects the x-axis at 2 points and the zeros of the polynomial minus 1 and 4. Are you clear, children? See the pictures? See, x-axis, y-axis. Here also the curve intersect the x-axis at 2 points. So here the number of zeros is 2 because the curve intersects the x-axis at 2 points. See this next picture. Here also number of zeros is 2 only because the curve intersects the x-axis at 2 points. See this one. Here the given graph y equal to p of x intersect the x-axis in only one point. So here the number of zeros is only 1. Here also the graph y equal to p of x intersect the x-axis at only one point. So here also the number of zeros is only 1. See this pictures. This is above the x-axis, either above the x-axis or below the x-axis. That is, intersection is not possible because this is above the x-axis. So here the number of zeros, no number of zeros. This graph has no zero because this graph does not intersect the x-axis. Here also the same reason only. See this graph. The graph y equal to x cube minus 4x. This is the y is equal to x cube minus 4x graph. See this graph intersect x-axis at how many points? 1, 2, 3. At 3 points it intersects. So here the number of zeros is 3 and zeros of the polynomial is minus 2, 0, 2. Do you know the difference, children? Zeros of your polynomial and number of the zeros? See this graph. This is x-axis. This is y-axis. Here the graph, this is the graph for y equal to x cube. The graph intersect the x-axis at only one point. So here the number of zeros is 1. 0 of polynomial is 0. See this one. Here the given graph y equal to x cube minus x square intersects at 2 points. Intersect the x-axis at 2 points. One point is at 0, another one is at 1. So here the number of zeros is 2. Zeros of a polynomial is 0 and 1. Example 1. Find the number of zeros of p of x. See the pictures. See the first picture. X-axis, this is x-axis, this is y-axis. The graph y equal to p of x intersect the x-axis at only one point. So, the number of zeros is only 1. See this graph. At 2 points, the curve intersect the x-axis. This is one point. This one is another point. So here in this picture, the number of zeros is 2. See this one. The graph intersect the x-axis at 3 points. This is 1 point. This is another point. This one is third point. So in this diagram, the number of zeros is 3. See this one? This straight line intersect the x-axis at only one point. So here the number of 0 is only 1. See this one? Here also the number of zeros is 1. See this diagram, the graph intersect the x-axis at how many points? 1, 2, 3, 4. At 4 points. So the number of zeros is 4 in this graph. Exercise 2.1. See all the pictures, children, which are in examples. See the first picture, x-axis, y-axis. The straight line intersect the y-axis only. It does not intersect the x-axis. So, this graph does not have no zeros, does not intersect the x-axis. Here, there is no intersection in x-axis. So, that it has no zeros. See this once again. The straight line intersect y-axis only. It does not intersect the x-axis. So, the number of zeros is nothing. That's mean it has no zeros. See the next picture. This graph intersect the x-axis at only one point. See? So, this is the graph. Here the number of zeros is only 1. See this picture. This graph intersect the x-axis at 3 points. The number of zeros is 3. See this one. This parabola intersect the x-axis at 2 points. So here the number of zeros is 2. In this diagram, the graph intersect the x-axis at how many points? 1, 2, 3, 4. 4 points. So here in this graph, the number of zeros is 4. See this one? Here the graph intersect the x-axis in 1, 2, 3 points. Yes. So this is the number of, here the number of zeros is 3 only. In this concept, we learned what is linear polynomial, what is quadratic polynomial, what is cubic polynomial, and general forms of linear, quadratic as well as cubic polynomials. Then zero of the polynomial and geometrical meaning of the zeros of a polynomial. Are you clear, children?